Hi everyone, and welcome to this lecture of precalculus where we want to discuss about domain and range of functions. In the previous videos, we talked about what functions are, some very basic properties of their manipulations and algebraic addition, multiplication, and so on. However, we want to focus this video only on domain and range of functions. So without further ado, let's get started. By the end of this video, you should have a clear concept of how to find domains and range of functions, and we will also talk about many examples and build an intuition on how to determine them. All right, so let's start. So let's say you have a function f of x equals to y. So that means y equals to f of x. This means y is a function of x. And very simple example could be taken as, let's say, 2x plus 1. This is a very simple example. Now, when we talk about domain and range, what we essentially mean is that we want to see what are the valid inputs and what are the valid outputs. That's it. So, informally speaking, domains correspond to valid inputs for which there are valid outputs. And I will talk about what do I mean by valid in a few moments, so bear with me now. And range corresponds to valid outputs. Now you may ask, okay, what is this term valid means? Well, it depends on which set of numbers or which set of functions that you are really operating on. Let's say you are dealing with only real numbers. Since this is precalculus, we will only talk about real numbers. So by valid inputs, I mean there might be functions. Um, let's say you put a real number in, but you get something very weird at the output, right? It can happen. For example, let's say you have a square root, and let's say this is x plus 2. Now you might say, oh, if I put any real number here, what would happen? Let's say x belongs to the reals, okay? So if you put any positive number over here, that's fine. That's absolutely fine. Even if you put -1, -1 and 1.5, that means 1.5, or -2, that's also fine. However, if you exceed -2, that means if you put, let's say, x equals to -5, then you will have something, and this gives you square root of -3. Now, when we deal with real numbers, we don't really know how to evaluate this, right? So in this sense, your -5 is not a valid input because it's generating something weird that does not fall under the set of real numbers. So what people usually do is people say we want to find inputs and outputs, that means the domain and the range, under this sort of a mapping. So f is something, some function that takes some input from the set of real numbers and maps it, or gives an output to real numbers. This will be our main focus. You can also go for complex numbers as well, quaternions and stuff, but since we are only talking about stuffs that are necessary for precalculus, we will restrict ourselves with this sort of mapping where you take an input from the real number set and the output also comes out as a real number. All right. Now, what do we mean by domain? Okay. Again, consider the simple example from the above, 2x plus 1. So this is 2x plus 1. As you can imagine, you can put any real number. So x can be any real number. And if you put that in, y will always be a real number too. So that means whatever x you put, y is always gonna be a real number as well. And in fact, when we talk about plotting, you will realize this is just a equation of a straight line. So what is the domain here? The domain is the input, right? Because informally speaking, domain means our valid inputs. So any real number, if you put it in the place of x, will give you something real as well, in the case of this example. So in this case, domain is the set of all real numbers. In other words, you can also write it mathematically like x belongs to R. This is your domain, like set of all reals. And what is the range? Range is the set of the valid output. So in this case, for any real number instead of x, you will always generate a real number as well. So the set will come off as a set of real numbers. So the range is the set of all reals, or y belongs to R. So for all, so this is a for all symbol. For all xi, by xi I mean an element. It can be the 100th element, I is just an index, 10,000 element and so on. For all xi belongs to R, yi belongs to R. And this set is called the domain, and this will be my range. All right. So yeah, this is how you figure it out. So whatever problem you have, the function you have, you just try to see for which set of real numbers as an input, you also get an output that is a real number as well. We'll see more examples and we'll see how to deal with different situations. So this is our example one. And let's go back a little bit and consider something very simple. Just a diagram. Let's say you have 1, 2, 3, 4. You have 8, 9, 6, -2. And you have a mapping like this. In this sense, this was your input, and this is your output. In other words, this is your x, and this is your y, which is just f of x. So what is the domain and range? The domain is just the set of all the inputs, right? So this is 1, 2, 3, 4. And the range is just, I'm calling it R, not the boldface R, as for the real number. So let's just write it like this. And the range is just 9, 8, 6, 2. It's as simple as this. The input to output. All right, so let's consider another algebraic example. This time, let's consider a fraction. So let's say y equals to x plus 2, and you have a x minus 2 over here. All right. So, and then I ask you, what is the domain and range? Okay, so the domain is pretty simple. We just want to figure out the valid inputs of x from the set of real numbers, right? So let's break down the problem in a few steps. So this is a fraction over here, and the numerator is just x plus 2. And you can easily realize for all x belongs to real, x plus 2 belongs to real numbers as well. No matter what you put, any real number. Any real number plus 2 is another real number. However, when you consider the denominator, x minus 2, you won't be able to write this like the stuff that we wrote over here. Why? Because as you can see, if you put x equals to 2, it will be a 2 minus 2 in the denominator. So 2 minus 2, if you put, you have 2 minus 2 in the denominator, which is 0. Now that's a bad thing. Why? Because nobody knows what some number divided by 0 is. This is a question. Now some people say, oh, this is infinity. Okay, that's simply not correct. Something by 0 is not infinite. This is something we call as an undefined. That means we don't know what it is. It doesn't make any sense. You can literally produce whatever you want out of it. So that's why we cannot put x equals to 2. However, instead of x equals to 2, you can put any real number. Instead of x equals to 2, you can put any real number and you will get another real number over here in the denominator. So one restriction that you found right now is that x is not equals to 2, right? But all other real numbers will work just fine. Just fine. So we don't have any problem in the numerator. However, we do get some restrictions about our choices for the input in the denominator. That is, we cannot choose x equals to 2. However, apart from x equals to 2, we can choose anything we want. So now we consider the fraction as a whole. We already figured out if there are any restrictions for the numerator. We figured out if there are any restrictions for the denominator. Now you can easily write the domain down. And how do you do that? So the domain for y equals to x plus 2 divided by x minus 2 is x belongs to R. I'm using an acronym. ST means such that x is not equals to 2. That means you can put any x you want from the set of real numbers. However, you cannot choose x equals to 2 because if you choose x equals to 2, even though the numerator is finite, the denominator becomes 0. As a result, the fraction becomes some finite number divided by 0, which is undefined. Undefined is not something that is defined in the set of reals, so we don't want that. So this is how you find this domain. I'm not writing it formally like, x belongs to R. I think this is the such that symbol, if I recall correctly. I don't exactly remember it right now. Like x is not equals to 2 and stuff. Yeah, but my point is, you make sure you understand what you're doing. If you understand what you're doing, you can just then pick up how to write things formally. So I'm not gonna do that right now. Like, not write things formally. I'll just write the words and yeah. And not to mention the fact I forgot how to write it. So that's another thing. All right. So this is one example. So this tells you if you are dealing with a fraction, you should look at the denominator first because on a fraction, when you have a 0 in the numerator, that's fine. 0 divided by something finite is 0. However, if you consider a 0 by 0 situation, that's a whole nother beast. It's also, again, you have a 0 in the denominator, so that's another, undefined thing. So the first thing you need to do is that whenever you deal with a fraction, look if the numerator looks okay. If it looks okay, go for the denominator. And the denominator cannot be 0. So because, you want things from the set of real numbers to the set of real numbers. And that's why you cannot make the denominator as 0. It's as simple as that. I'm not sure if there are any sets that, includes the undefined. So I'm pretty sure you won't find it anywhere. Even if you take complex numbers, quaternions, and stuff like that. All right, enough talk. Let's move to the next example. I think this is our example number 3. All right. Now let's do something. Oh, sorry. I'm supposed to talk about finding the range of this function. Yes, I forgot about that. Range. Okay, so now you say, oh, I found the domain as x belongs to set of reals apart from x equals to 2. How do I find the range? One thing, if you notice, is that range are the valid numbers that takes the position of y, right? Like the range is just a set of the valid values of y. So why don't we do something? Because in this case, let's say our intuition is bad, we can just, just think about like, oh, will it be all real numbers and stuff like that? Because it's a fraction and anything can happen. So what are the possible values of y that we can get from, our set of inputs? So this gives you another idea. If you look at this fraction, you can easily see that you can solve for x and put y on the right side. And since your goal is to find the valid values of y, you can just use the technique you use to find the domain to find the valid values of y. And that will be your range. Let me show you how this is done. So we have this thing at our hand. Now the first thing I'm going to do is that I'm going to solve or try to solve, because there will be cases we won't be able to solve for y that easily. X in terms of this, like this time x will be written as a function of y, or we can call it x in terms of y. So let's try to do that. This is very easy. This is y x minus 2y x plus 2. We want to solve for x, so let's pull all the x on the left side. This is y minus 1, and this will be equals to 2 plus 2y, and x is equals to, am I making a mistake over here? Nope, we're all good. All right, so this is y plus 1, and then you have y minus 1 over here. All right, so we solved for x in terms of y as 2 times y plus 1 divided by y minus 1. Now, the second step will include use the techniques introduced above to find the domain. I will just use this quotation marks because this is really not the domain, it's the range. It's just a way of making people understand the first time they see it. Domain of y, and this is your range. This will be your range. All right, so let's go to another page. So our x is equals to 2y plus 1 divided by y minus 1. And you can see for any y belongs to real number, the numerator is fine because something real plus 1 is just something real. However, you have this y minus 1 in the denominator, so you say y cannot be equals to 1. Other than that, everything is fine. So the range is just y belongs to reals, however, y will never be 1. That's all it is. And you can see why this is true, because if you put y equals to 1 into this equation, you will get x plus 2 equals to x minus 2. And you can cancel this x's off, and that will give you 2 equals to minus 2, which does not make any sense. And right? Because 2 is not equals to minus 2. So that's why we say this y is not equals to 1. And that is what we found from here. You can get this sort of restrictions and you can actually put them in the equation that you started with, and you'll see that something really goes wrong if those restrictions are not there. So that's how this whole idea of domain and range works. Now, let's move on to the other example. This one will come with a square root. So let's say you have something like this, x plus 2. How to find the domain and range? Well, pretty easy. If you put any x belongs to R, this does not necessarily give you a real number for y. If you take, let's say, x equals to minus 3, you'll have something square root of minus 1, and that doesn't make sense in this when you're dealing with the real numbers only. Again, you try to find some restrictions, right? When you try to deal with real numbers, your square roots, anything that is underneath the square root has to be 0 or something greater than 0, because we are taught that in real numbers, whenever you deal with real numbers, negative numbers does not give you any square roots and stuff like that. But when you study complex numbers, this negative one is just I. This is the imaginary unit and stuff. But okay, now we will not talk about this stuff in the pre-calculus thing. If you are interested, complex number, I have a playlist of complex analysis. I'll just put that down in the comment box below. If you're interested, you can check that out. Like the first 2 or 3 lectures should be good enough to give you the basic ideas of complex numbers and how they work. So yeah, do check that out if you're interested. I'll just put it in the description box. All right, so our goal is to say, find x's so that this doesn't turn out to be negative, right? Like this x plus 2, it doesn't turn out to be negative. So we say x is always greater or equals to 0. That's what we mean by we don't want it to be negative. Now, whether 0 is a positive or negative number, as far as I know, 0 is a positive number. That's the end. That's it. So this really gives you x is greater or equals to negative 2. And this makes sense because if you put negative 2, let's say you put x equals to negative 2, y equals to 0. If you put x equals to negative 1, y equals to square root of negative 1 plus 2, which is just 1, and so on. And you can put any positive number like 4, it will become square root of 6, and so on, and da da da. So the domain is just x belongs to R such that x is greater or equals to negative 2. It's as simple as this. What about the range? Well, for range, like we did before, we need to solve for x, right? So let's try to do that by squaring both sides so that we can get rid of the square root. And now you have x equals to y squared minus 2. Now, for any y belongs to real number, y squared minus 2 is also a real number, right? So there are no restrictions over here. So the range is just y belongs to real. And that is it. It's as simple as this. However, the way we are solving it right now, you won't be able to solve it all the time. So most of the time, what people do is that for range, some equations are not possible to solve analytically. So what people do is that they love to plot graphs of functions. We will see that in the next video, hopefully. And hopefully I'll make use of some Mathematica that will help you guys to visualize what is really going on. So for this video, we'll just focus on the analytical part, and in the next video, we'll try to visualize what we have been doing so far. So bear with me. Now, let's consider another example. Let me choose a pretty color. What is a pretty color? I don't know. Magenta? Is this magenta? I don't know. All right, so I'm not sure what number of ex like what is the number of this example. I think I lost it. Oh, this is example number 5. All right, so let's try to do something complicated right now, because we have some basic ideas. Uh, let's try to do something complicated. Instead of numbers and stuff, let's try to, be all smart and deal with symbols. So let's say we have y equals to ax squared plus bx plus c. As you can see, this is the standard quadratic equation where I'm telling you a, b, c, they all belong to real numbers. I ask you again what is the domain and the range, and you can see easily that for any x belongs to R, or for all x belongs to R, y equal, ax squared plus bx plus c, this belongs to R. And so that's the domain. The domain is just R, the set of all real numbers. Oops, I shouldn't put second. Now, now, uh, so this is your domain R, and sorry, my headphone just got disconnected, and I'm not sure what just happened. All right, so now we want to talk about the range. We can solve for x as if, like y is not equals to 0, right? Y is equals to something. So what we can do, like this solution. If you don't know, let me know in the comment box below, like how to solve it, so that I can show you how to solve it. No middle term breakups, just standard formula that can be derived. So if you have this sort of quadratic equation, you know how to solve it. And in case you don't know, again, let me know in the comment box below. Maybe I'll make a very short video about how to get the formula. So if you know that, what you can do is that you can take x squared bx plus c minus y on one side and put it to 0, and then write x is equals to minus b plus minus square root over b squared minus 4 times a times, instead of c we have a c minus y, so this is c minus y divided by 2a. This is what x is. Now whether x is a real number or not totally depends on the term under the square root. So we require b squared minus 4ac minus y to be greater or equals to 0, right? So this tells us 4ac minus y is less or equal than, like, obviously this goes over there. Oh, I think I forgot basic algebra. Wait, how to do this? This is a minus, yeah, they go away. So this is b squared. Now we need to find the restriction on y because, y is over here. So c minus y is equal or less than b squared minus 4a. Or you can write c minus b squared by 4a is equal or less than y. So what we get is the restriction that y is greater or equals to c minus b squared divided by 4a. Now, how does this make any sense? Well, a, b, c, they're all real numbers, right? So if you can just plug in some numbers, you can easily see. So the range will be such that y belongs to reals and y is c minus b squared divided by 4a. Now you can ask, okay, show us an example where these are, a, b, c, and numbers, because if you're seeing all symbols for the first time, you can get a bit confused, and that's absolutely okay. So let's consider a very simple polynomial, like a quadratic polynomial that is x squared plus 2x plus, instead of c, let's take 1, instead of b. So there's a 1 over here, so a is equals to 1, b is equals to 2, c is equals to 1, right? Again, domain, for this example, domain is just x belongs to R, and range is just y greater or equals to c is 1, so this is 1, minus b is 2, so 2 square is 4 divided by 4 times 1, and again this gives you 1 minus 1, which is equals to 0, so y is greater or equals to 0. So whenever y is greater or equals to 0, you know, like that only makes sense, right? Because all these numbers over here, a, b, and c, they're positive. So what you do is that you can put any x squared will be positive. However, this x can become negative, right? But you may wonder, okay, is there any x for which y can be less than 0? Well, it's not, because you can easily simplify this and you can see this is just x plus 1 whole squared. This will not be the case always. This is a very simple example, and you can see that whatever we found over here makes sense with this guy. So this is how you can cross-check things. I think we talked a lot in this video. I think I should make another video on domain and range because there are more interesting examples. So I'll end this one here today, and hopefully in the next video we will solve more examples, like more interesting one, not just the boring textbooks one. And then we will see some plotting. Like plotting is not that difficult, it's pretty easy. So yeah, this is it for today. And if you think our contents are helpful, do help us by giving us a thumbs up. That helps with the algorithm, and do consider subscribing. We are almost on our way to 300 subscribers, and I hope to bring you all my videos have been so far about mathematics, like the applied mathematics that we use in physics or engineering. Since I'm a physics major, I do plan to make some videos about the research that I do, and maybe some classical mechanics lectures and some quantum mechanics lectures. So I do have some plans for this channel, and I hope you guys will be with me, and let's see where it goes. All right. Okay. Thank you.